Today we are going to learn how to solve the optimal value problem. So step 1 is you need to determine the function that to be optimized. Step 2, you need to differentiate the function. Step 3, you need to find the value of x when dy dx is equal to 0. And step 4 is you need to use first derivative test or second derivative test to determine the maximum or minimum relative. And step 5 is to find the conclusion. So first we look at the example. An open box with a square base is to be made from a square piece of cardboard that measures 12 cm on each side. A square will be cut out from each corner of the cardboard and the sides will be turned up to form the box. Find the dimensions that yield the maximum volume of the box. So here you need to find the dimension of the maximum volumes. So the side of the box we will get 12 minus 2x here. The first step is you need to find the function that to be optimized. So the function here is the volume. So we know that the volume is length times with width times with the height. So the length here is 12 minus 2x and the width also 12 minus 2x and the height is x. So the function that we got here is 12 minus 2x squared times with x. So step number 2 is you need to differentiate the function. So we have to differentiate the volume. So we can use the product rule. Then we got 12 minus 2x squared times 1 plus x times negative 4. 12 minus 2x. And then you need to simplify the function. And then you will get 12 minus 2x, 12 minus 6x. Okay, step number 3, you need to find the value of x when dy dx is equals to 0. So when dv over dx is equals to 0, you will get 12 minus 2x, 12 minus 6x equals to 0. So when 12 minus 2x equals to 0, you will get x is equals to 6. And then 12 minus 6x equals to 0. And then you will get x equals to 2. So next, step number 4 is you need to use first derivative test or second derivative test to find the maximum or minimum relative. So here is we use second derivative test. So you need to differentiate again. So we get 12 minus 2x times negative 6 plus 12 minus 6x times negative 2, which is we use product rule. And then you need to simplify the equation. And the last one we get 24x minus 96. So you need to find when x equals to 6, does d square v over dx square, you will get 48, which is greater than 0. So it is relative minimum. And then when x equals to 2, d square v dx square, you will get negative 48, which is less than 0, so it is relative maximum. So from here we can conclude that the maximum volume is when x equals to 2. So you substitute x equals to 2 into the function volume, so you will get 8 times 8 times 2, so it is the maximum volume. So the dimension that yield the maximum volume is 8 times 8 times 2.